Hey guys, welcome to the video for writing standard form. We are in Unit 3B. Our essential question is, why are multiple representations important? So we've spent some days talking about writing slope-intercept form equations, and then previous to that, we learned how to write point-slope equations. So if you want to kind of just look at the breakdown, we first looked at point-slope, which is the second two right there, and then we talked about slope-intercept, and now we're going to move on to standard form. So to review what standard form is, that's the form where it looks like ax plus by equals c. This one's different in a few reasons. This is the only form that has a, b, and c in it, and then slope-intercept doesn't really count because the b there is lowercase, but this is the only form where a, b, and c are mentioned, and also x and y are on the same side of your equal sign. So in every other form, your y and your x are always on opposite sides of the equal sign, and here it's on the same side. And I just want to make a note that A, B, and C represent numbers. So normally you'll see a number there. You're not going to see like the A, B, and C values, but you should be able to identify them if you are asked to. Before we move into actually writing in standard form, we're going to have some practice just talking about the setup and why it looks that way. So for the practice, we have $18. So you have $18, apple juice costs $3, and orange juice costs $4. So they've set it up an inequality for us here. So let's go ahead and start off with the first note is that it says 18 over here. Well, where did that 18 come from? Well, it says that you have $18. But do you have to spend $18? No. That's why there's an inequality sign. If there was an equal to sign, that means if it was equals, you'd have to spend $18. But here, we just need to spend either less than $18 or up to $18. So you can spend up to $18. But you don't have to, right? Like you could just pocket all that $18 and you don't have to spend any of it. That's why there's an inequality sign. And this is in standard form. Your A here is 3, your B would be 4, and your C value would be 18. So it is in this form up here. All right, the next thing we're going to talk about is, where did the 3x and the 4y come from? Well, how much does apple juice cost? Apple juice costs $3. So we know that that's where the 3 comes from, right? So we know that apple juice costs $3. So the x is going to be the number of apple juices purchased. So number of apple juices, or apple juice bottles, right? So that's going to be the number of apple juice bottles times 3 because it's $3 for each one. $3 per bottle, $3 per apple juice bottle. Okay, the y values must represent the orange juice bottles then. So this will be the number of orange juice. Okay, that's where the 4y comes into play because it costs $4 for every orange juice bottle. All right, so that's just kind of some information. So we're working backwards. They gave us the equation or inequality, and we're determining what x and y are based off of that. Okay, so moving on to number 1. At a back-to-school sale, Maggie can purchase any pair of pants for $18 and any shirt for $6. Her parents tell her that she can spend at most $120. So before we even start this, we have to talk about the two things we're talking about. So back in the last question, or last example, we were talking about apple juice versus orange juice. So you can buy either or, and your total has to either be less than or equal to $18. Well, here we're talking about pair of pants and number of shirts. So go ahead and identify our variables here. So pair of pants will be our x. It doesn't really matter. So x can be the number of pants. And make sure you put the number of. So if you just put x equals pants, I'm like, what about the pants? The color of the pants, the size of the pants? So make sure you put the number of the pants. Okay, and then any shirt. So y is going to be the number of shirts that we purchase. Well, what do we know? We know that we can purchase pairs of pants for $18. So 18 is going to be attached to our x value. So $18 for every pair of pants, right? That's why we multiply. So for every or for each pair or per pair of pants. And then we also know that we're going to add that total to the amount of our shirts, right? We know that we can buy shirts and we know that they're $6 each. So that means $6 per shirt, 6y. Okay, well, and then it says at most 120. So does Maggie have to spend $120? No, she can spend less than $120. She doesn't even have to spend any of the $120. She could just pocket the money, right? So it says at most, so this tells me this is not going to be an equal sign. It's going to be an inequality, which means however much she has to spend has to be less than or equal to 120. Why not greater than or equal to? Well, you can't spend what you don't have. She can't spend more than 120 because then she'll be out of money and she doesn't have that. So that's the most that she could spend, and that's how the inequality that represents that situation. Okay? Well, using this inequality, what are three possible combinations? So when we're talking about possible combinations, it's basically talking about what are some possible combinations of pants and shirts she could buy. Is it possible for her to buy 0 shirts and 0 pants? Yes, because that's still less than $120. So the point 0, 0, which means 0 shirts, or 0 pants, I'm sorry, X is pants. So 0 pants and 0 shirts. So she could buy 0 of both. Okay? Now, I know we only need 3 here, but I'm going to go ahead and do 4 just for fun, right? So could she buy just 1 of each? She could. She could buy 1 pants and maybe, let's say, 2 shirts. If she buys 1 pants, that's going to be $18, and if she buys 2 shirts, it's going to be $12. Well, that only equals $30, so she's still good there. So she could buy 1 pants, or 1 pair of pants, and 2 shirts. So let's think about some extremes here. What's the most amount of pants I could buy? Well, if I'm looking at the most amount of pants I can buy, that means I can't buy any shirts. So let's say I buy 0 shirts. So our Y value is shirts. So let's say we buy 0 shirts. What's the most amount of pants I could buy? Well, I could do 120 and divide that by 18, and I get 6.6 repeating. Well, does that mean I can buy 6 pairs of pants or 7 pairs of pants? Would I round up? And I would say, no, you can't round up, because if you try to buy 7 pairs of pants, you don't have enough money, because 18 times 7 is 126, and we don't have $126. So the most amount of pants you could buy is 6. So you could buy 6 pairs of pants and 0 shirts. On the opposite spectrum of that, let's see if we buy 0 pants. What's the most amount of shirts we can buy? So if we have 0 pants for our X, let's figure out how many we could buy for our Y. Well, if I don't buy any pants, I need to do 120 divided by 6, and that's going to give me 20, which means the most amount of shirts I can buy is 20 shirts. And if I buy exactly 20 shirts, it's going to equal $120. So it's literally the most I could spend. So 0 pairs of pants and 20 shirts. Okay, so basically you're given possible combinations. It doesn't have to equal 120 because it's an inequality. You just have to make sure you're spending less than 120. Okay. Moving on to number 2. During a basketball game, the home team scored 20 points, and their score was made up of, and I made a mistake here, and I fixed it already on your notes, but I forgot to fix it on here. But this should be 3-pointers, not free throws, because free throws are only 1 point. So the home team scored 20 points. Their score was made up of 3-pointers worth 3 points and layups worth 2 points. Write a linear equation in standard form. So we're talking about a basketball game, and there's 2 ways you can score. You can either score by having 3-pointers, or you can score by having layups. So those are going to be our 2 variables. Remember, your variables are the things you don't know. Well, we know how much they're worth, but we don't know how many we scored. So let's make our X value be the number of 3-pointers. And let's go ahead and make our Y value the number of layups, because we're comparing the layups to the 3-pointers. Okay, now, how much is a 3-pointer worth? A 3-pointer is worth 3 points. So that would be 3 points per 3-pointer. And then you know you're going to add that to the total of layups that you have. Well, layups are worth 2 points. So since Y is our layups, we're going to have 2Y. Well, and for a fact, you know that the home team scored 20 points. So they did score 20 points, which means that you have to put that they did score it, which means that their layups and 3-pointers together are going to equal 20. This is not an inequality, because you know it's going to equal 20 points in the end. That's for a matter of fact. They scored that much. Okay. So that is our equation. Now, what are 3 possible combinations of free throws? Oh, this should be 3-pointers. I'm so sorry. 3-pointers. What are the 3 possible combinations, or what are 3 possible combinations of 3-pointers and layups the team could have scored? Now, it's saying possible. We don't know how many of each they scored, right? We know for a fact they scored 20 points, but we don't know how many layups it was and how many 3-pointers it was. So really, we're just giving 3 possible cases. It doesn't mean that that was a matter of fact. So all of the things that I'm going to show you are just basically, I'm trying possibilities. So sometimes it's just guess and check until you get a good answer. So we're going to have to use the equation here. The reason why you can't just pick any 2 numbers, like in the last problem, is because it has to equal 20. So in the last problem, she had $120 to spend, but she didn't have to spend all of it, right? It didn't have to be equal to 120. She could have bought 0 pants and 0 shirts and didn't spend anything. But I can't do that here. I can't score 0 3-pointers and 0 layups and get 20 points. And that's not counting free throws. So let's pretend like we're not counting free throws. It's just layups and 3-pointers. I can't score 0 of both and get 20 points somehow, right? So it does have to equal 20. So we're going to have to use our equation that we came up with. 3x plus 2y equals 20. Well, we said that x counts for the number of 3-pointers and y counts as the number of layups. So let's just guess. Let's say we made 0 3-pointers. So let's plug in a 0 for the x because we make 0 3-pointers. Remember, x is 3-pointers, or the number of 3-pointers. Y is the number of layups. So let's say we score 0 3-pointers. So we plug in a 0 for x. 3 times 0 plus 2y equals 20. Okay, well, 3 times 0 is just 0. Oops, it's just 0. So we have 2y equals 20. Let's go ahead and get y by itself. Divide both sides by 2. And get y equals 10. Well, what does y represent? Y represents the number of layups. So that means that if I score 0 3-pointers, right, the 0 for our x value, if I score 0 3-pointers, I made 10 layups to get those 20 points. So this means 0 3-pointers and 10 layups. And that's going to equal 20 points. That's one possible combination. We have to come up with 2 more. You know, I'm just coming up with random stuff. So let's say we decide to make 1 layup. Let's say in the whole entire game, it's just 1 layup. Again, you could have different answers than me, but I'm just coming up with 3 possible combinations. So you could have different combinations than me. So I'm going to try and plug in a 1 for our layup. Let's say that we only score 1 layup. Let's try to figure out how many 3-pointers we would have to get. So 3x plus 2 times 1 equals 10. Remember, y represents the layups. I'm looking to see if I made 1 layup, how many 3-pointers it would have to be. Oops, I put a 10. It should be a 20. So sorry. Okay, well, we have 3x plus 2, because 2 times 1 is 2, equals 20. We want to get x by itself, so we have to subtract 2 first. We have 3x equals 18. Divide both sides by 3. The x equals 6. What does that mean? Well, that means that if I score 1 layup, I have 6 3-pointers. So our x value is 6. The y value that we plugged in was 1, which means if we score 6 3-pointers and 1 layup, it will equal 20 points. Okay, now I have to come up with 1 more possible combination. Again, it could be really random. You just have to make sure it does equal 20 in the end. So if I score 6 3-pointers, that's 6 times 3, which is 18, and then 1 layup is 2 points, so 18 plus 2 is 20. They have to equal 20 points when you add them all up. All right, so let's go ahead and just do another, random one. Let's see. Let me think of one. Let's do 4, what's it called? 4 3-pointers. Let's see what happens if we do 4 3-pointers. Remember, it's a 3-pointer because that's where our 3s are. Y is our layups. So let's test if we do 4 3-pointers. So 3 times 4 plus 2y equals 20. 3 times 4 is 12 plus 2y equals 20. subtract both sides by 12, 2y equals 8. Divide both sides by 2, and we have y equals 4. What does that mean? Well, y was our layups, right? Y is the number of layups. So that means 4 layups and 4 3-pointers is going to give us 20 points. So our solution could be 4, 4. That's a possible solution. So we could score 4 3-pointers and 4 layups. Again, these are just possible combinations. There could be more than 3. They could be more or different combinations. All right, so that is it for these notes. I apologize for my typos of writing free throws instead of 3-pointers, but that's just setting up standard form equations. So basically being able to pull information and then creating an equation or an inequality based off of that. If you have any questions, please feel free to come into tutorials.